Welcome everyone to the very first episode of 8 Minutes of Ew. I'm your host, Miss Mallory, the curious conservationist and self-proclaimed grossologist. Today we are learning all about the creepy cool science behind the 8-legged, web-walking acrobat known as the spider. But don't press stop just yet, because even if these creatures give you the heebie-jeebies, the science behind them just may turn your ew into a ooh. So let's get started. Have you ever found yourself exploring a dark place and walked through a spider web? I don't know about you, but when I walk through a spider web, I immediately become this crazy cool ninja, trying to karate chop my way through the invisible threads. But what's crazy is spider silk may seem thin and frail, but it's one of the strongest fibers on Earth, more durable and elastic than any natural or synthetic fiber, including Kevlar, which is used to make bulletproof vests. And it's 6 times stronger than high-grade steel, per weight, of course. The only substance found to be stronger than the strongest of all spider silk are the teeth of limpets, which are a type of aquatic snail with a cone-like shell. I'm pretty sure you've seen one if you've ever been near a tidepool. Incredibly, spider silk doesn't start out as thread like what we see, but as droplets of liquid protein. As it passes through the spider's silk spinning organs, or known as spinnerets, it makes contact with air and becomes a solid. Crazy cool, right? Spider silk is so amazingly complex that humans still can't replicate it. And trust me, we want to replicate spider silk. It's a flexible, durable, lightweight, and incredibly strong building material. Imagine what our buildings, our bridges, or even our clothes would look like if it was made out of spider silk. Unfortunately, movies and stories have made spiders out to be super gross and creepy, right? But they are perfectly designed for what they do. Spiders have 2 body segments. The front segment is a cephalothorax, which holds the spider's eyes, fangs, stomach, brain, venom glands, which we'll go about later, legs, and little leg-like things that help them hold on to prey, which are called pedipalps. The second part of the spider is called the abdomen. So we have cephalothorax in the front, abdomen in the back. The abdomen is where many of the important organs of the spider lives. We're talking about the digestive tract, reproductive organs, lungs, and spinnerets. Have you ever wondered what the inside of a spider looks like? Well, let me tell you, it's pretty fascinating. Many assume a spider's insides would look similar to that of a human's, but it is so different. Let's start with the circulatory system. Humans and other vertebrates, or animals with a backbone, have a closed circulatory system. Our blood moves from the heart and lungs to the rest of the body through veins and arteries. So the blood is closed or enclosed in veins and arteries. A spider's circulatory system is open. They don't have veins to transport their blood. In fact, they don't even have true blood. A blue-tinted fluid that acts like blood is pumped throughout the body by a long tubular heart that lines the back of the abdomen where the backbone would be if it had one. Wait, spiders don't have backbones? Nope. Spiders are arachnids, which are 8-legged arthropods. An arthropod is an animal with jointed legs and an exoskeleton, meaning their protective skeleton is on the outsides of their bodies, unlike ours, which is on the inside of our bodies. In order to grow, spiders and other arthropods will shed their entire exoskeleton all at once. It's a process called molting. But even though spiders have a lot of things that are different from us, we actually have something in common: being hairy. But spider hairs are so much cooler than our hairs. If you think Spider-Man's spidey senses are cool, then prepare to be blown away by spider hair. You see, humans rely a lot on their sense of sight to learn about the world around them. Spiders, on the other hand, rely mainly on their sense of touch. Hair touch, that is. All the information they need about the world around them can be gathered by sensory hairs covering their body. No joke. Different types of hair relay different types of information. For example, some sensory hairs can tell the spider what the air temperature is, or if a storm is approaching. Meanwhile, other types can help some species climb walls, recognize chemicals, and even detect airborne vibrations from the wing beats of an approaching meal or the presence of a predator. But personally, I think the coolest hairs a spider can possess are the defensive ones found on American tarantulas. When threatened, the hairy spider, yes, tarantulas are spiders, will brush their back legs rapidly across the back of the abdomen, sending up a cloud of these barbed defensive hairs into the eyes, nose, or mouth of a potential predator. The spider escapes while its pursuer is distracted by an eyeball full of microscopic splinters. Ouch. But you may be asking yourself, why wouldn't the tarantula just use its venom and bite the bully? Well, because that venom is very important to a spider. It's the only way a spider can eat. Imagine you didn't have teeth to chew your food. Instead, like the spider, you had a straw-like mouthpiece to slurp up your meals. So how would you eat your pizza without teeth? Well, you would have to turn your pizza into a pizza smoothie. And that is exactly what spiders do with their saliva. Important enzymes in the spider saliva not only paralyze its prey, but will also start digesting it from the inside out, turning the insides of the fly into a slurpable soup. Now, this venom or saliva uses up a lot of energy to make, and that energy comes from the food the spider eats. So if the spider uses a lot of venom to protect itself, that means the spider has less venom to catch flies, replenish their energy, and make more venom. So let's think about this a different way. Imagine you worked all summer to save enough money to buy the coolest collectible of your life. And you can't wait to put it on your shelf and admire it for many, many years. However, as soon as your little brother or sister sees it, they want to play with it. Well, are you going to just hand over your new prized possession? Of course not. I mean, you just worked your tail off for over a month to get this thing, and you know they would break it in a matter of minutes. Instead, you're going to try to trick them into wanting any other toy in your room before you let their chocolate-covered hands touch your new treasure. Well, same for a spider. It doesn't want to use that precious venom it's worked so hard to make, unless it absolutely has to. So remember, no spider really wants to bite you. However, a defensive spider will bite if it feels like there's no other option. So it's best to admire all spiders with our eyes and not our hands. Well, aspiring grossologists, my time is about done. But I want to hear what you think now that you've learned the science behind the spider. Ask an adult to send me a message about your thoughts. You can find me on the Miss Mallory Ventures website or on Instagram. And I hope the next time you see a spider, your ew becomes an ooh. Thanks for joining me, everyone. See you next time.